Alrighty, hello there. This is Mrs. Oliver bringing you today's lesson. I hope you had a great weekend and are ready to finish up our last 3 weeks of 7th grade. All right, so today's focus is going to be solving one-step inequalities. Okay, so our objective is that we will graph the solutions to an inequality. We have to be able to write an inequality given its graph and solve a one-step inequality and graph its solution on a number line. Okay, so we know how to do one-step equations, and what we know is the difference of equations is there's an equal sign, whereas inequalities are less than, greater than, or less than or equal, greater than or equal symbols. Okay, so this is part of our last unit, trying to wrap up the rest of our pandemic year. Okay, so you're going to have 3 pages of notes today that we're going to go through. Okay, it might seem like a lot, but some of it's a lot of review, and some of it will go easy. Okay, so your first one is going to go the first page you glue in. All right, so here we have our symbols. Okay, we have our less than. Okay, so I'm going to type in our words. This is the less than symbol, whereas this one is our greater than or equal to. This one's just greater than. And this one's the same one. I think we meant one of these here. Let's fix this one. Let's change this one. Scribble that out. We want less than or equal to. Okay. So let's scratch this one out. Less than or equal to. And the only reason what changes is that little line underneath. That includes the number that we're talking about as our solution set. Equal to. Okay, so that just got rid of. We used our less than, our greater than, less than or equal to, greater than or equal to. All right, maximum. So the most that something could be. So that one, we could put the maximum. Oops, sorry. Writing. Let me zoom in some and make your writing a little bit easier. Something that's above. Okay, that means this number has to be larger than the other given. Okay. No more than. Let's go here. Oh, wait. Nope, that one's going to go over here. No more than. Fewer than. So it has to be something that is smaller than another. No less than. So that means it can be that number and bigger. At most. It's going to be this one. We have less than or equal to 7. At most, I can have is 7. Okay, smaller than. So that means this one. No greater than. No more than, or no more than. I'll go this one. If it is more than 8, it has to be greater than 8. Below, I'll go here for less than. More than, we already did that one. At least is going to be this one. If we say at least 5, it has to be 5 or bigger. And larger than would be this one. All right, so we used all those words. If you need to, pause this and fill them in. I know my writing's probably a little hard to see on there. All right, the next part is choose an equality for each situation. Okay, so we have x is greater than 10, x is greater than or equal to 10, x is less than 10, x is less than or greater than 10. The temperature today will be at least 10 degrees. So that means x is greater than or equal to 10. Okay, so that means it's going to be 10 degrees and bigger. And the temperature is going to keep increasing. Okay, the temperature tomorrow will be no more than 10 degrees. So that is going to be our x and less than. If you notice, these are some of our keywords right here. Yesterday was less than 10. So x is just less than 10. That means it was 9, 8, 7, negative 20. All right, last Tuesday there was more than 10 inches of snow. Ooh, that's a lot of snow. So that one's going to just be x is greater than 10. So that means we got 10.5 or 11. All right, so then we have graphing. We have a is greater than 3. Okay, so I don't want to include 3 as my solution set. So that's why we put an open circle, because that means it's not a possibility. 3 is not a possibility. And x is greater than, so or a is greater than. So we go which way the numbers are getting larger. So anything greater than 3 is part of our solution set. R is less than or equal to negative 2. So we find our negative 2, and because it has that little line underneath of it right there, that means we include 2 as our solution. Negative 2 is a possibility. And then we go where the numbers are decreasing. Okay, so that's your first page of notes. Okay, now we have graph each one still. We have 7 is, or W is greater than or equal to 0. Notice there's no numbers. You fill them in yourself. So we know there's 0. To the left of 0 is our negative numbers. Okay, this is 1, this is 2, 3, 4, 5. This is negative 5. Now because there's that line underneath, you're going to put your 0 with a solid, and we're going to go where the numbers are getting larger. Those are all possible solution sets. B is less than or equal to negative 4. Okay, same thing here, still 0. There's negative 2, negative 4, 2, and 4. So we have the line underneath. So at negative 4, you're going to put your solid dot, your closed circle is what they like to call it. I'm going to go where my numbers get smaller, to the left. All right, what do you think you're going to do with number 9? J is greater than 5. Think about that. I'm going to put some numbers down. Well, we're going to want the open circle. If they're getting greater, we're going this way. Now, do I always have to start right there? Could I put 5 in the middle? Yes. Okay. If you get larger numbers and they're not going to fit on there, you can put them different. I was just trying to keep them kind of similar so you could see where they would go. But if I wanted, I could put 5 here, and then 3, 1. There's my 0, 7, 9. Still open circle, and I can go that way. A number line you can manipulate as long as you're keeping it balanced. Okay. All right, now write the inequalities. The temperature today will be at most 50 degrees. So that means, is 50 degrees included? Yes. Now, at most, that means that's the highest it's going to get. So x has to be anything that is 50 and smaller, so that is x is less than or equal to 50. Okay, so that was our keywords there. The temperature tomorrow will be above 70 degrees. Okay, so that means x has to be greater than 70. Yesterday, there was less than 2 inches of rain. So we know 2 is what we're using because that's our number. And do I have to use x? No, it's just the easy variable to choose. Less than. It just told you what symbol to use. You use the less than symbol. Last Monday, there was at least 3 inches of rain. If I wanted, I could use R for rain. At least. So that means 3 is included, and it was anything 3 and larger. Okay. All right. T is less than or equal to -2. All right. So I'm just going to put 0, -2, 2. Okay. Less than, and it is the equal. So I go where it's getting smaller. So I know -5 is a possible solution. -2 is a possible solution. -1, -100. Those are all possible solutions to say those numbers are less than or equal to -2. J is greater than -5. So if we wanted, I could put -5 here, -3, -1. There's 0. There's +1. -7. All right. This time it's an open circle. Doesn't have that little line. Oop, I'm going the wrong way. It said greater than. And we go this way where all the numbers get bigger. All right. Y is greater than or equal to 0. All right. Notice I try to make sure I know where my positives are going. I know where my negatives are going. All right. So we're at 0. We got that little line underneath. So it's a closed circle. And we're greater than. So I'm going to go this way. All right, B is less than 1/2. Now this is where it can get a little tricky. Now, if I wanted, I could use this where I know these are all each integers, like we normally do. And my half would be right there. That's one way you could do this. But then I would have to put an open circle. If that's too cramped for you, it's too cramped, that's not enough room, put your 0th and put a 1 here. Then that's your half. Okay, and it's going to go this way where all our numbers get smaller. That's where the part of you can manipulate the number line to work to your advantage. Okay, so then that means this would be 2. This is -1. All right. So now moving on to the next page. Solve inequalities by adding or subtracting. So we want to look at this just like when we did equations, one-step equations. You want to use the inverse operations. Okay, so remember doing inverses? What's the opposite of adding? You subtract. What's the opposite of subtraction? You add. Then make sure you follow the integer rules. Okay, so if I gotta subtract 2 on both sides, we get x equals 9, right? Then if I wanted checking work, I go is 9 plus 2 equal to 11. Yes, 11 equals 11. Remember checking that work? All right, so then our next step is graph it. Now this is where it gets different with, all right, so say here's 8, 9, 10. I want enough space, so I'm doing halves. Okay, here's 9. If x equals 9, I just put a dot there. Is no other possible solutions. That is the only solution. That's where inequalities and equations become different. Okay. Same thing though, the process is about the same. We still use our inverse operations, and now we say x is greater than or equal to 9. Then I can check my work again. Okay, remember doing that checking. It's still important. Is 9 plus 2 greater than 11? Well, no, it's not. So we would have to go with anything. So when we graph this, and we get 11 greater than 11. So when we do this, and we still have our 8, our 9, our 10, and 11, because there's not that equal sign underneath, we can't put a solid dot. This is where checking is a little bit different. Okay, so I put my open circle and where x is getting bigger. So if I used 9.5 plus 2, is that greater than 11? Well, I get 11, and a half. Is 11 and a half greater than 11? Yes. So that does work. Okay, you can check with anything bigger than the ones it said. Okay, let's check again with m minus 4. Well, that means you're really adding 4, but then you have to follow those integer rules. Same signs, add and keep, different signs, subtract. You owe me $15, but you give me 4. So that means you are going to owe me still $11. Okay. Negative numbers, remember, as they approach 0, they are different. Okay, so like 0 would be all the way down there. So if I was to check this, is negative 11 minus 4 equal to negative 15? Well, you would have to add your opposite to make it really plus negative 4. And we do get negative 15 equals negative 15. Okay, so I would just put a big old dot right at negative 11. And that's it. That's the only possible solution. We do the same steps for the inequalities. Okay, minus 4, or not minus, plus, my bad, we're adding. M is less than or equal to negative 11. So when we checked that one, okay, is negative 11 minus 4 less than or equal to negative 15? Well, negative 15 less than or equal to negative 15. It does work. See what I mean by it's different when you have this equal? All right, so then same thing when I have my negative 11, negative 9, negative 8, negative 7, negative 5. That means this is negative 13. I put a solid dot this time because there's that line, and less than. Where do the numbers always get smaller? Okay. All right. So remember, when you're adding a negative, okay, I could say I'm subtracting a negative half on both sides, subtract a negative half, but then you need to come in and add your opposites. If I'm really adding an opposite, I'm really adding a positive. So those really give me then a different sign. Remember, different signs, you cannot add them. You have to subtract for the greater value on top, because then these cancel. So G equals, and it's going to be a negative number, because this is my greater value right there. With that being the greater value, I got to do some borrowing. So that's 13. So I get 1.8. So there's my answer. It's a negative 1 8/10. Okay. So if I have a negative 1 here, that's a negative 0.12, a negative 1.4, 4, 2, 4, 6, and a negative 1.8. So negative 2, negative 2.2, negative 2.4, negative 2.6, negative 2.8. Okay, so we just put a dot right there. I kind of skipped by 2/10. Okay, or if we have enough, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So this is negative 1. That's 0.1, 0.2, 0.3, 0.4, 0.5, 1.5, 6, 7, 8, 9, and negative 2. All right, let me erase all those little dots. We're going to do the same concept. We're going to subtract a negative half on both sides. So minus a negative half, which really means I'm adding, but then at the same time we have different signs. So that's where it gets, you're adding the opposite, you're adding a positive, which means we have different signs. So negative 1 and 8/10 is less than or greater than G. Now, this is where some students will make some mistakes because it's flipped. If it's easier to know, you put G is still greater than or equal to negative 1 and 8/10. All I did was basically take it and flip it all around. Okay, I saw that this side is still open towards the G, so when I rewrite it, it needs to be open towards G. All right, so that's my 0.5, 6, 7, there's our 0.8. And that's where it's getting bigger, so we're going closer to 0. Then we have fractions. Remember fractions. What do you have to have when we do any type of fractions? Common denominators. Okay, so what are numbers that 3 and 5 can both go into? Okay, so we have 3, 6, 9, 12, 15, 5, 10, 15, right there. That's our common denominator. And whenever I multiply the bottom by our denominator, I'm going to multiply the top by the same thing. So I multiply by 5, I multiply that by 5, multiply that by 3, multiply that by 3. So I really have C minus 1 and 10/15 equals 4 and 6/15. Now, what's the opposite of subtraction? Addition. So we're going to add to both sides. And this is where we probably needed a little bit more room. I'm just writing really big. So you add to both sides. That makes that cancel out. So C equals 10 and 6 makes 16. And a 5, but that's improper. So we have a 6 and 1/15. That's going to be a hard one to graph. All right. That's a 6 and it's a 7. Another good way to go through that one, where's this mouse, was 1/15 as a fraction or as a decimal. Not even a 0.1. Okay, so that is 6.5. That's 0.5. We're about right here. That's about where we're at. That's a nice little estimation. And now remember, with the equal sign, there's no arrows to go. And you would do the same thing with the other one. Okay, we would add our 1 and 10/15 to both sides. Okay, and get C equals the 6 not equals. Not bad. Less than. I'm stuck on equations. Less than 6 and 1/15. All right. So now, am I going to do an open circle? No. Or yes, an open circle about right there is going to be less than. So everywhere that we get smaller. All right, write an inequality and solve a problem. 2 less than a number is less than 9. So we have a less than 9. A number, 2 less than a number. So that means we started with a number and we took away 2. Okay, so the opposite is adding 2 to both sides. So n is less than 11. And then you just make your, oh, I didn't say to graph it. On your homework, you'll have to graph. This, we're just practicing writing an inequality. Sonny has at least 68 envelopes to address. At least. So that means he is doing 68 or more. He has addressed 17 of them. Write and solve an inequality that describes how many more envelopes Sonny has left to address. So we have envelopes, and he's already done 17. Or she. Subtract 17 on both sides. And how many envelopes must we still do? 51 or more. Okay, you can go over and beyond. Gotta look for those keywords. Those are what's going to help you. 2 less than 10. If I add 3 to both of these, okay, this becomes 5 is less than 13. This becomes 2. Oh, that 2. Right, add 2 to it, you get 4 is less than 12. 3 is less than 11. Subtract 1, I get 1 is less than 9. Subtract 2, I get 0 is less than 8. Negative 1 is less than 7. So see, nothing changed there, right? All we did was change the numbers, but our inequality sign stayed the same. So if I add 15 to each of these, I get 5 is still greater than negative 5. If I added 10 to it, I would get 0 is still greater than negative 10. What about if I add 5 to it and negative 5 is still greater than a negative 15? If I took 5 away, I'd end up negative 15 is still greater than negative 25. Negative 20 is still greater than negative 30. And negative 25 is still greater than negative 35. All that is to show you when we're adding or subtracting inequalities, it doesn't change the inequality sign. It is always consistently the same. Okay, so let's try it now with multiplication or division. If I divide both by 3, okay, I get 6 is greater than, okay, if I divide both by 2, I get 9 is still greater than 6. Divide by 1, that doesn't change anything. Is greater than, I'm sorry, my greater than starting to look like 7s. But those are the greater than signs. Now, if I divide by negative, I get negative 18 and negative 12. Is negative 18 still greater than negative 12? No, it is now less than. If I divide by negative 2, I get negative 9 and negative 6. That becomes greater than or less than. And then if I divide by negative 3, I get negative 6 is less than negative 4. All right, what about over here? If we divide by 4, I get negative 10 is less than 5. Negative 20 and positive 10. Well, that's a less than. And then this means it's the same. Now, if I switch it and I have positive 40 and negative 20, well, it switches my sign. I'm now greater than. If I divide by negative 2, I get a positive 20 and a negative 10. That's greater than. 10 and negative 5. So notice what happens once we go to the negatives. So multiplying or dividing by a negative changes or flips the inequality sign. Okay. All right, so there's a guided practice. So let's practice that. Okay, this is it. And then it's your homework time. All right, what's the opposite if we have multiplication? We have multiplication, you are going to divide. Oops. If we have division, we're going to multiply. Okay, this is multiplication, remember? So we're going to divide by negative 4. Remember, I'm dividing by a negative. So I still keep my m, but now it's less than or equal to a negative 5. Okay, so if this is 0, say this is negative 1, negative 2, 3, 4. Here's my negative 5, positive 5. I put a dot, and I'm going this way. Okay, now this one is division. What's the opposite of division? Multiply by the reciprocal, which is really, because remember, there's that invisible 1 right there. So you're basically flipping your fraction that you're multiplying by to get those to cancel. But because I used a negative, it's now greater than. And 2 negatives make a positive 108. Now, I don't have 108 over here, but I can kind of estimate. We can put 100 here. And go by 2s, 102, 4, 6. Here's 108. Okay. And it's an open circle. And we're going to go where our numbers get bigger. Okay, so you don't always have to have 0 and go by 1s. You can go by 2s. All right, divide by y. To get y by itself, we divide by 10. Now, is my 10 negative? No. So my inequality stays the same. And because I know on your homework, you need to check your work, so let's check our work. Is 10 times negative 5 less than or equal to negative 50? Negative 50 is less than or equal to negative 50. So that works. Yay. Okay, so negative 5 is my answer set. So I have negative 5 here, 0, positive 5. And it is a dot, and it goes that way. Ooh, multiplying by your visible 1 to the party. You got 1.2 over 1 on both sides. Multiplying by 1.2. Now it's a negative. Oh, look, did you see that's an equal sign? I know my answer is a negative. So 2.3 times 1.2. 6, 4, add your 0, 3 and 2, and add them. 6, 7, and 2. Ooh, why did I put a 3? But drawing happy there. 2. And 1, 2 hops, So 1, 2, my dot goes right there. Okay, so we can have, there's my 2, there's my 3, 1, 2, 3, 4, 5, 6, there's 7. So right in here, just put a dot. That's where your answer goes. Alrighty. Okay, so now you have 10 problems to do. Okay, some of them are word problems, some of them are not. Look, you have room. You have to check your work. Okay, so what's the opposite of subtracting? Adding 21. Add 21. Now those are different signs, so I have to take 21 and subtract 16 from it to get 5. So A is greater than 5. And I'm going to check it. Is 5 minus 21 greater than negative 16? We get negative 16 greater than negative 16. Well, you know what? Since we want to know if something's greater than, what number is greater than 5? 6. So let's use a number greater than 5. 6 minus 21 is negative 15. And is negative 15 greater than 16? Yes. I rather owe only $15 compared to owing $16. So then we make our answer in here. You can put like a 0. Oops, nope. Okay, we need some 1, 2, 3, 4, 5. I don't care. 1, 2, 3, 4. There's my 5. So then we put our open circle and show that we're going that way. So here you're going to have to make your own number lines. Okay, let's look at number 3 now. Divide by negative 7. Remember, that changes it to be y greater than negative 5. So when we check our answer, choose a number bigger than negative 5. So it's negative 7 times, let's see, what's a number greater than? We can use 1. That's bigger than, it doesn't matter. It doesn't have to be the next number. Is that going to be less than 35? Well, I get negative 7 less than 35. Is that true? Yes. So our answer is, in fact, y is greater than negative 5. So 1, 2, 3, 4. I can put negative 5 here. Put negative 3, negative 1, negative 7. Put an open circle and go where they get bigger. Okay, so you got some more problems to wrap up and you'll be good to go.